In this video, as we can see, there are different graphs of different functions such as position functions, velocity functions, and acceleration functions. As we can see on the top right side of this video, we can see a position function which shows the movement of an object over time. The second graph shows a velocity function. It shows the speed of the object over the time with direction, which makes the velocity function. And in the bottom we have the acceleration function. Now we are going to check the position function and velocity function and see the effect of derivation on them. As we know, derivation means the slope of the tangent line on each point. So in the distance function, if we take the slope of the points one by one and we start from point 0, we can see on the velocity function it also shows 0. As we can go on, we can see from point 0 to point probably 4, we have the increasing rate in the tangent slope. So we do have an increase in velocity graph. From point 4 to point 6, we have the same slope. It doesn't increase or decrease. So we have on the velocity function, we have the same constant positive value, but it's constant, doesn't change. From point 6 until point 24, we have until point 15, we have an increasing amount of slope. So we can see that the graph here goes down, and as soon as we reach at the top of the graph, we will see we have a horizontal slope, which the slope will be equal to 0, and as we can see on the velocity graph, it also shows us 0. After point 15 until point 24, we have the increasing in amount but negative side. So we're gonna have a negative value but increasing on velocity. From point 24 until point 26 or 7, we have an decreasing slope. I mean, the value of the velocity decrease, but it's still a negative sign. And from point 26 until point 30, we're gonna have a same constant slope of horizontal. So it would probably give us 0. Now we're gonna check the velocity function and the acceleration functions. As we can see, again we start from point 0 and it goes up to here until point 4, which is going down the same point on the acceleration graph. As we can see, the slope is increasing but it has the same constant. It has a positive slope, which the acceleration graph shows that it's 4, but it doesn't change over the time from point 0 to point 4. So we're gonna have a constant value of 4 on the acceleration graph. From point 4 until point 6, as we can see, we have a horizontal slope here. So horizontal slope shows us that it's 0. So on the acceleration graph, we also have 0. From point 6 until point 24, we have the same decreasing amount of acceleration function slope, which shows that our acceleration graph must show us a negative value but a constant one, because it doesn't have any change in the rate of slope. So we can see it's negative to constant value until point 24. From point 24 until point 7, we're gonna see that we have an increasing slope here, but it's still constant. It's not curved. Therefore, we're gonna have a constant value also for this point, which is the graph shows us it's still like 4. And after that, we're gonna see that the graph is constant on 0, so we don't have any acceleration here.